Hello and welcome to today's online lesson for GCSE Physics. Today's learning intention is to know the difference between scalars and vectors. Now for the starting task, I've presented you with a problem here that you might be familiar with from earlier down the school. We've got Mr. Fieldhouse with his pet spider that leaves his garden gate and walks 4 metres forwards. He then walks 3 metres to the left, and the question is how far away is the spider from the garden gate? Now I'm going to ask you to pause the video, work this out in whichever way you prefer. There is more than one way of working this out, so pause the video and then press play to see if you get the question correct. So to do this question, I would have started off by drawing out the path that Mr. Fieldhouse's pet spider takes, which was 4 metres forwards and then 3 metres to the left. Now, if you're a good mathematician and you've done Pythagoras' theorem already, you would realise that you can actually do this on your calculator now by doing the square root of 3 squared plus 4 squared, which gives you 5 metres in this case. However, if you don't want to do this by Pythagoras' theorem, we could instead do it by a scale drawing, which would have meant drawing a 4 centimetre line and a 3 centimetre line, and then when we join them up in that shape that's a triangle, you would see using a ruler that length there is 5 centimetres. So the scale we would have used would be 1 centimetre is actually worth 1 metre. Now in the exam, it doesn't matter which method you use, whether you use Pythagoras' theorem or whether you do it by drawing this out using a ruler. Now, in today's lesson, I'd like us to be able to describe the difference between scalars and vectors. I would like us to be able to explain why distance is a scalar but displacement is a vector, and then we've just seen from the starting task there how to draw a scale diagram to find an unknown value. A scalar is any physical quantity that has a magnitude but no direction. Now, a magnitude you can think of as being either the size or a number associated with something. So, for example, if I said that I was walking at 5 metres per second, that 5 would be the magnitude that we're talking about because it's the number that goes with it. And of course, the direction you could think of as being which way you are facing, which way you are pointing. Now, a scalar doesn't have a direction. A scalar only has a magnitude. If something has both a magnitude and a direction, then we say that it is a vector. And because it has a direction as well as a magnitude, then that means that we can represent a vector using an arrow on a diagram. So if you think of the various diagrams that you've drawn already, we've drawn forces using arrows already. So forces will be a good example of something that is a vector. Now we've got on the board here a story. It's not a very exciting story, I must admit, about Ahmed taking his morning routine going to school. What I would ask you to do now is pause the video, read through this task and then note down which of the quantities are scalars and which of the quantities are vectors. In class I would normally give this out as a worksheet and ask you to underline the scalars and highlight the vectors. So it says that Ahmed takes 40 minutes to get ready in the morning. That 40 minutes is the first quantity that we have. Now 40 minutes does not have a direction, and because it doesn't have a direction, that would make this a scalar quantity. It says he usually eats 50 grams of cereal. 50 grams, again, would be a scalar because it doesn't have a direction. You can't say, for example, he has 50 grams north of cereal. That wouldn't make any sense. Likewise, the 200 millilitres of milk that he has is also a scalar. Now it then says he walks 10 metres from the kitchen to the bathroom. Now if we know he goes from the kitchen to the bathroom, then that means we have an idea which direction Ahmed is walking in, and so we say that this is a vector. However, he then brushes his teeth with 2 centimetres cubed of toothpaste. 2 centimetres cubed is a volume, and that is of course a scalar quantity. Now to get to school he has to walk 2 kilometres in total. Again, 2 kilometres in total doesn't tell us which direction he actually walks in because he might not walk in a straight path, for example. That is a scalar. Now it says it stops at his friend's house, which is 800 metres east of his house. Now 800 metres east is of course a vector because it tells us the direction as well as the magnitude. After picking up his friend, he walks 1,830 metres north. That includes a direction, so we say it is a vector. And then finally, the doors at the school are heavy, so he has to push against the door with a force of at least 100 newtons. That one I would forgive you for forgetting that could be a scalar, but forces are vectors. We know which direction they act, and because it says he pushes against the doors, then that means that the force is going in the direction towards the door, so we know that that is actually a vector. Now, after school, he goes for a 5 kilometre jog in the park. That is, of course, a scalar. And it says it takes him 40 minutes. 40 minutes, again, it is a scalar quantity because it doesn't have a direction. He aims to burn at least 500 calories. 500 calories there, sort of an amount of energy really. That, of course, it is a scalar, doesn't have a direction. 15 minutes, again, is a scalar. The fact it's 15 minutes to walk back to his house, that doesn't count as a direction because time itself is just 15 minutes. It doesn't have a direction. But then 500 metres southeast does have a direction, making that a vector quantity. Now, there are some specific scalars and vectors that we actually need to be aware of for the GCSE exam. The first one is distance. Now, distance is how far an object has actually moved, but it doesn't tell you the direction that it's moved in, and so we say that it is a scalar quantity. Now you can see on the diagram there that long path there that's drawn in by the blue arrow and is labelled with the purple text, that is the distance that he actually moves in this journey. It doesn't tell us the direction. Now the displacement is how far an object has moved in a certain direction, and because that does take into account direction, we say that it is a vector quantity. Speed is how far an object has moved in a certain amount of time, and that is a scalar quantity. Velocity, however, is speed in a given direction, and we say that that is a vector because it takes into account direction. Now, if we look at the picture on the board, we can see there are two cars, and both of these cars have the same speed. They're both moving at 25 metres per second. However, the car on the left is moving to the left, and the car on the right is moving to the right, so they are travelling in opposite directions. That means then that they have opposite directions, of course, as I've just said. The way we show that with velocity is that one of them is positive and the other one is negative. It doesn't matter which one we say is positive and which one we say is negative, as long as one of them is plus and one of them is minus, to signify that they have the opposite direction. Now, we need to know how to calculate speed. Speed is calculated by this equation, which is speed equals distance divided by time. I would write that down in your notes if I was you and learn it, because it's one of the equations which is not given to you on the equation sheet. Now, speed is measured in metres per second, distance is measured in metres, and time is measured in seconds. You could well be asked in the exam to put this rearranged to work out either a distance or work out a time, and if that is the case, of course I would recommend that you draw an equation triangle. Now what I see quite often in class is that students get this triangle incorrect, because what will happen is that they will automatically put speed at the top because the equation is written speed equals. However, that is not the rule for drawing a triangle. The rule that we have for drawing a triangle is that if things are being multiplied together in the equation, then they need to be put on the bottom of the triangle. But in this equation, nothing is being multiplied. Instead, we have something being divided. That means that the thing that goes on the top is the first thing in the division, which in this case would be the distance. Now, I'm not going to write out the whole word using this pen. I'll just write the word d there for distance, and because that is divided by time, the time needs to go on the bottom, which means that the speed needs to take the remaining gap in the equation triangle here, so I'll write as an S there to represent the speed. Now in the next lesson we'll have the opportunity to practice using this equation triangle with some practice questions.